What's up everyone, and thank you for choosing to learn with LAM. Today we're going to be talking about solving for hydrates. Now, the process for solving hydrates is very similar to the process for solving empirical formula, so you might want to take a look at that video first. But if you're all ready to go, then let's do this thing. First things first, let's make sure that we're all clear on what hydrates are, and we'll use calcium chloride dihydrate as our example. Hydrates are made up of an anhydrate, which is what we call the ionic compound in our hydrate, so in this case calcium chloride, and water, which is, well, water. The anhydrate and the water are always in a particular ratio, which is why we can solve for it using mole ratios like with empirical formula. Alright, let's jump into a sample problem here. A 50.0 gram sample of barium hydroxide X hydrate contains 27.2 grams of barium hydroxide. What is the value of X? So basically we're looking for the number of moles of water per mole of barium hydroxide. In a hydrate problem, you only really need two pieces of data, which is the mass of the anhydrate and the mass of water. So the mass of barium hydroxide is 27.2 grams, but we don't quite have the mass of water. However, we can find it by subtracting the mass of the anhydrate from the hydrate, since that leaves us with just water. So 50.0 grams minus 27.2 grams gives us 22.8 grams of water. Similar to empirical formula, we're going to set up our particles vertically, but notice that I'm listing the anhydrate and the water as opposed to each element individually. This is because we're looking for the ratio between the anhydrate and the water, and not the ratio between elements. So I'll divide each mass by its respective molar mass, and I'll show a quick sample calculation here. And that gives me 0.159 moles of barium hydroxide and 1.27 moles of water. To create a nicer, rounder ratio, I'm going to divide each mole by the lowest number of moles, which in this case is 0.159, and that gives us 1 and 8. From here, I can create the formula for my hydrate and show that there are 8 molecules of water for every formula unit of barium hydroxide. We call this barium hydroxide octahydrate. And that's that. As always, if you have any questions, just leave them in the comments. Good job, everyone. If you find that you need a little extra help, please feel free to check out my other videos for tips and tricks on how to succeed in school. And as always, thanks for learning with LAM.